Hello, in this video we're going to learn how to draw the VSEPR structure for ClF5. First we want to identify the different types of atoms that we have. We have chlorine and we have fluorine. Chlorine is going to give us 7 valence electrons. Fluorine is also going to give us 7 valence electrons. If we look at our bank, we have 5 plus that, 6 times 7 electrons is 42 total electrons to work with. We want to place the less electronegative chlorine in the center. We'll do a spoked wheel kind of thing. Place fluorine on the outside here. We had 42 electrons in our bank. We just made 5 bonds worth. Wasted 5 bonds worth of electrons. Well, we didn't waste them, but we used them. We have 32 electrons left over. If we start filling out the octet on our fluorines here, we're going to give them each 6. So we use 6 electrons on each fluorine. There were 5 of them. We had 32 electrons minus 5 times 6 electrons. It's going to leave us with 2 electrons left over. Those 2 electrons need to go on that center atom. Now we can draw in our bond dipoles. We're going to be pointing out towards the electronegative fluorine. Your bond dipoles should always be pointing towards fluorine because fluorine is the most electronegative atom. And we can do our steric number. We have 1, 2, 3, 4, 5, and this lone pair counts as 6. Now we need our lone pair number. There is 1 lone pair on that central atom, so our lone pair number is 1. We come down here, we go to the steric number of 6 and the lone pair number of 1. We see we get a square pyramid. So the electron geometry is going to be octahedral, the molecular geometry is going to be square pyramid. We need to interpret that image for our case here. So what they're telling us is that we're going to have chlorine. There's going to be a fluorine pointing straight up. There's going to be a lone pair pointing straight down. Going into the board on either side, there's going to be fluorines coming out of the plane of the paper, or the screen, I guess, in this case. We are going to have fluorine. Sometimes I draw these a little bigger, just to kind of help you with that perspective. We want to put all our lone pairs on there. We can't forget to bring those along. So this is octahedral, but square pyramid. So if you imagine these 4 here making it like a square base that are going to connect to that top one there, you can kind of see the pyramid, kind of like the ones in Egypt. The electron geometry is going to be octahedral. The molecular geometry is going to be square pyramid, square pyramidal, depending on if you want to use that as an